Being able to define your own functions is a superpower for programmers. And in this lesson, we're going to take a look at the exact syntax you need to know in order to define your own functions and call them. But first, let's take a look at the calling side and think about, well, if we're going to define a function, in order to be able to call it, there's got to be a relationship between these two things. So let's take what we already know about function calls and think in terms of another built-in function, which is the max function. So max is a function that, for our purposes, we give it two integers as arguments or as inputs to its algorithm, and it's going to give us back the greater of those two. Well, what do we need to know about a function call and function call syntax in order to use it? We have to give the function call a name. So what function are we referring to? And then some parentheses. And inside those parentheses are going to be our arguments. In this case, I'm going to use a slightly contrived example and say an argument of 10 plus 1 and an argument of 10. Right? So let's break down what each of these components of a function call is in order to understand what it is that makes up a function call. Because when we write our function definitions, there's going to be a close relationship between these things. The first thing that we specify here is the name of our function, right? So a function definition must have a name, and so the function call refers to that name. So the name of the function is important. This allows us to know what function we're referring to when we're trying to use a function call. Next, we're going to see parentheses, a pair of them. And inside those parentheses, we're going to have an argument list. So I'm going to say that this is the second piece, and I might just draw an inclusive set of a brace here to say that all of this, from the starting parenthesis to the ending parenthesis, this is what we call our argument list in a function call. So let's make a note of this. This is the argument list. And you'll notice I use the word list here because in this case, there are two arguments, right? So I'll use a different color, I'll call this argument A and argument B, right? And they're separated by that comma. So when you have a function that has multiple inputs that it expects, those inputs will be given by the function call and they'll be specified, separated by commas. Now, I did something kind of funny here. I used 10 plus 1. Notice that's an integer expression, right? This is an int operator, the addition operator. So when this expression evaluates, it would result in an int. So the argument list is made of expressions. And this is important to recognize because that means we have a lot of flexibility in how we actually call our functions, right? I could have used variables here if I had two int variables, like say x and y. I could have used x and y as arguments here. Any expression that we want to use as an argument is valid as long as its type matches up with what the function expects. So the function definition must be able to specify, hey, in this particular argument position, you need to give me an integer in this example. Or in the print function expects a string. So we must, when we define a function, be able to tell the function definition what type of data we expect in each of these argument positions. Now, the third thing that's important about a function call is that a function call itself is an expression, right? This whole piece of syntax here, this is an expression. I'm going to erase the A and B in order to say that this entire piece of syntax, which is the function call itself, is an expression. And that expression is going to result in some value, right? So in the max case, if we ask what is the max of 10 plus 1 and 10, well, if it's an expression and it has to evaluate down to a single, in this case, integer value, that's going to be 11. 11 is greater than 10. So there's going to be some resulting type. So the function call results in a type or returns a specific type of data. And I'm going to use the word value here because when this is evaluated, when the interpreter actually gets to the point of interpreting this piece of code, this function call, it needs to boil this down to a single value, which would be, say, the value 11. And because this evaluates to an integer, we could use this anywhere we wanted to use an integer. So I could have, a function that's like, x is, say, an int variable, and assign it the result of this function call expression if we wanted to. Right? So this is our function call syntax. Let's take a look at how we can transfer this knowledge of a function call over to what a function definition would expect. We're going to define our own implementation of a max function. So as I mentioned, max is built into Python. And what I'd like you to do is in VS Code, go ahead and start a new Python file. So I put mine in my lessons directory. I right-clicked new file, and under lessons, I named this file function_def. And what we've got here is a function definition. And a function definition has a specific syntax that's made up of a number of key ideas. We're going to break down each of these ideas in concrete detail very shortly. But for now, I want you to go ahead and pause the video here and set up a file just as I have it with this function definition of the myMax function. And once you're done, go ahead and resume back. All right, so what is going on in this function definition? This is our first function definition. Well, let's actually take a look at the syntax piece by piece. On this particular board, I've gone ahead and set up the exact same syntax that you saw in VS Code and that you've written. So what did you actually write? What was this code? Let's break it down into three big parts, and then there's a really important, the very first line of a function definition is so important, we're going to break that down even further and talk about each of its pieces individually. So this first line is what we're going to call the signature line. And the word signature is kind of funny. I actually think that until you're a little bit deeper into computer science, signature is a less helpful word than contract. And but just to be precise here, let's call this our signature. And I'm going to write in quotes, contract. All right, so why is this the contract? And what does that mean? Well, when you think about what a contract is an agreement between two people. Someone, let's say it's an agreement between a buyer and a seller. And the seller is going to provide some service and the buyer is accepting some conditions of that service. And there's an agreement between these two things. Well, in a very similar sense, the first line of a function definition is telling anyone who wants to use this function definition, here are the requirements for you to use me. And here we'll get into breaking this down a little bit more specifically. We're defining the name of this function as myMax, and we're saying it has two parameters. You need to give me two arguments. Both of them need to be integers in order for me to do my job. And then this last little piece is saying I'm going to result in a single integer value. That's what you can expect back from me. And that's the contract of this function definition. The rest of this is sort of the implementation and the documentation of it. So the second line here, the blue line, is our docstring, and this should look familiar. Right? So our docstring is for documentation. The docstring of a function is describing how to use it. It's made for people to use as reference. If they're looking at a function definition and they want an English description of what it does, the docstring is there for that purpose. And I'll show you in just a moment how this actually is useful in VS Code as well when you're going to use a function. Right? And this third bit is a block. All right. And so just like we had in an if-then statement, this is our body that is a block. So I'm going to call this the body block. These are the steps that the function will take when you call it. Right? This is the subprogram. These are the statements that will be evaluated whenever we make use of the myMax function. Right? So let's actually break down this function signature a little bit more closely and talk about its individual pieces. The signature line of a function definition is its most important component. That's not necessarily fair. For someone using a function, and when you want to go and call a function, it's the most important part of the function definition because it's all you should need to know in order to use it. The implementation is actually probably the more important part, right? You don't want a buggy implementation. The implementation is what really matters. Under the hood, and if you want to write correct programs. But from a user's perspective, when you write a function definition and you want to go and use that abstraction, the signature line tells you everything you need to know in order to use it. Right? So let's break down this function definition. A function definition begins with the def keyword. Right? So the def keyword is a special reserved word. And this is saying I'm kicking off a new definition of a function. And that is what signifies this is a function definition statement. And when the interpreter reaches a function definition statement, it's not going to go ahead and follow through each of those instructions. It's effectively saying, okay, here comes a recipe. Let me save this as a recipe that's named whatever we name the function. All right, so this is the def is a special reserved word that begins a function definition statement. All right. So what follows the def keyword? Well, the name of your function. All right, so this is what you're naming your function. The name of your function has rules that are the same rules as what you can name your variables. So it's an identifier. So the name of the function is an identifier. And you get to name your functions whatever you want. We try to choose meaningful names. And so in this case, actually, rather than writing name here, let's go ahead and use the same, this was mymax, was what we named the function we're about to go tinker around with. And so this is an identifier we use to just put a name to the recipe or the algorithm that or the sub-program that we're about to actually define, right? And same rules as variables. Typically, we'll name in Python, our functions with lowercase letters and separate words using snake case with underscores. All right. Okay. Next comes the parameter list. So I'm going to use blue for the parameter list. Right. So blue, we had our parameter a, which is an integer. And this should look familiar, right? So this should look kind of like variable declarations, because these kind of are variable declarations. They're a special kind of variable called a parameter that is specific to the idea of a function. So this is our parameter list. And the parameter list is surrounded by parentheses. And I'm just going to shorten parens, surround list of, and I'm going to put in quotes here, variable declarations or var decals, variable declarations. And we'll see that these aren't exactly variable declarations, right? But it's very close. We're saying there's a parameter whose name inside of this function definition will be a and its type is integer. We expect the first argument of this function call to be an integer, and b is the second parameter. And this order matters. So the order and types of parameters. And you'll also see the word parameters shortened to params matters greatly in how we actually use the function and how we define it. All right, so our parameter list is parentheses surrounding a list of variable declarations, kind of. And the order of those matter. They're separated by a comma. All right, so if you want to have multiple parameters to a function, you have this comma that separates them. Okay, and next we have our return type. So following the last parenthesis, we're going to have what looks like an arrow, but it's made up of a dash and a greater than symbol, and our return type. So integer and a colon. Right. So the return type is important. It tells us when a function call is made to this function, what type will the result be? Right? It tells us the type a function call results in. So in this case, if we were to call the mymax function, we know that it's going to give us back an int value. Right? So whenever we call mymax, we know that it's going to give us back an int, and it's going to result in an int when it is evaluated. And we can take that int and do whatever we want to do with it. We can store it in a variable. We can use it in an arithmetic equation. Whatever we can do with an integer, we can do with the result of calling my max. Now in this example, all three of these types are the same, but there's no need for that to be true. We could have had a function that took in two strings and returned an integer. You can have a function that takes in two integers and returns a string. There's no assumed relationship beyond what the meaning of the function is between the parameter types and the return type. You can declare them however your function needs. They are all independent of one another. All right, so let's actually try calling the function that we wrote and taking a look at that in VS Code. If we were to run this particular function or this particular file, we'll see that nothing happens, right? And let's do that before we actually demo the code. So python-m, I wrote this in my lessons directory, lessons.function def, right? Nothing happened, right? There's no output here. And that kind of makes sense. We don't have any print statements and we never called our function mymax. So let's try calling the function mymax and printing its result. So let's print the result of mymax, and we'll give it a first integer argument of 10 plus 1 and a second integer argument of 10, right? From the example we tried previously, all right? Let me make this just a little bit smaller so maybe we can fit all of this on one screen. There we go. All right. So I'm going to try running this example one more time. And notice that 11 was printed out. So our function was called. mymax is the function we defined. And in the next video, we'll look at exactly how these arguments are passed to these corresponding parameters, and then what happens inside the body of a function and what these return statements mean. They're a special kind of control flow statement that causes a result to be sent back to where that function call expression was encountered, right? But hopefully there's some intuitive sense that, okay, well, if we printed mymax of 10 plus 1 and 10, we got 11. We could also have a second line where we print, okay, mymax of, let's call it 100 and negative 50. Let's make the second argument bigger this time. So negative 50 and 100. And I try running this program. And notice that the first line of output was 11. That was the result of this first line of code. And the second result was 100. Now, because this is a function that returns to us an integer, or that means when we call this function, it's going to evaluate down to an integer result, we could store that result in a variable. So I could say, okay, result is an integer and it's going to store the result of mymax, and then we can print that result, right? And this will have the same effect, right? We won't actually in our output be able to notice any difference, but if we looked in the memory of this program, we would have stored the result of mymax negative 50, 100 in the variable named result, and then printed out that variable's value later. All right. Now, one thing that I want to just mention while we're here is if we had tried to call this function, so print mymax 1 and 2, we're going to see that there's an error here, right? So if you see those red underlines and you hover over it, it says mymax is not defined. Now, as a human looking at this piece of code, you're thinking, wow, that computer, it's right there. It's literally right here. What are you talking about? It's not defined. But you have to remember that when our programs are interpreted, the default mode in which Python is moving through understanding our program and evaluating it is first it starts with this line, nothing to do, just a docstring. And then it gets to this line. It's like, okay, I need to make a call to mymax. And it's like looking around in memory and what it's seen so far. And it's like, do you know what mymax is? Anyone seen it? Was it a built-in? No, it's not a built-in. It's not in globals. It hasn't been defined anywhere. It wasn't imported anywhere. I don't know what this is, right? Even though it's defined on the very next line of code, because the definition hasn't been encountered yet and it hasn't been evaluated yet, the Python interpreter doesn't know about it, right? And so you can't call a function before its definition has been evaluated. And we'll look at some strategies for making that more of a non-issue in the future, but that's why our calls came afterwards. And if you tried to put them above the function definition, they wouldn't work. All right. The last thing I want to mention here is the relationship between the signature and the call. And this is an important distinction to make now that we've seen both of these things, all right? So notice we've got a call in this first line. This was the call to the mymax function. And our signature or our contract or the first line of our function definition here. So what's similar and what's different? One of the first things that you notice is different is only the signature is going to have this def keyword. This is when we're defining a function, right? And so that's one of the first clues that you'll have available to you to know that you're looking at a definition for a function rather than a call to a function. Because otherwise these look kind of similar, right? The next thing you'll notice is that there's a correspondence between the name, and that makes sense, right? So the name needs to line up, right? The only way that you know which function to call, given what we know so far, is by having defined it with some name, and then you're later referring to that name in order to make use of it, right? This is a lot like, when you order something off of a recipe or off of a menu, the name that you give for that item on the menu is what the chef is going to know to follow the recipe of. Same idea. And then we see some parentheses. Now, what's kind of confusing when you're first learning how to program is, well, it seems like, this part of each of these examples is exactly the same, right? But remember, this def keyword means that we're looking at something very different. Here, we're looking at the definition. And so we're going to see that this is the parameter list. So these are our params. And in the top example, we're looking at an argument list. And our arguments do need to correspond to our parameters. We'll talk more about this in the next lesson where we look at exactly what happens when a function call is encountered. But notice that this first argument, 10 plus 1, that's an int expression, and that corresponds to the type of the first parameter. So there's a one-to-one correspondence between the type of the argument and the parameter that corresponds to it. Similarly, we have 10 that corresponds to the second parameter b of our function definition. So this 10 argument corresponds and lines up, it matches with b. And there's exactly 2 arguments and parameters. So there's, again, a correspondence between the arguments that we give a function. We know what those need to be, or the types that they need to be, by looking at the function definition's signature and looking at its parameter definitions, right? Notice that these are expressions. And this is important, right? The expressions of your arguments are how we have more flexibility and control over how we use our functions. Parameters are not expressions, right? When you're defining a parameter, these are effectively variable declarations, which aren't expressions, right? So a big difference there. So if you see expressions, you know you're looking at a function call, and those are argument values. And then in the function definition, you're going to see, and we're going to require, for our purposes, a function return type, right? And the return type tells us what this function call will evaluate to when you use it, right? But you're not going to see the return type in a function call. In a function call expression, the return type is implicit. It's implied that when you call this function, we know that it's going to evaluate to an integer because that's how the function was defined, all right? And lastly, when you see the signature, it has these the colon at the very end of it in order to say, okay, what follows after this is the actual definition, the actual recipe, the implementation, the procedure for the processor will follow when this function is called. Okay, so this was a quick introduction to the syntax of functions, both the calling side of a function and the definition side of a function. In the next video, we're going to take a look at what actually happens. What are the steps that our interpreter goes through in order to make a function call and evaluate it? We're going to look at what happens in memory, how are our arguments passed into our parameters, and then what happens, how is it that a result is returned back from inside of that function call to wherever the function call was made. Great work moving through today's lessons.